In this video, we are having a look at a presentation that I created specifically to present at the Master Speaker Academy classes organized by the Dutch Java user group, which was held at the Open Value headquarters in Utrecht-Zallen on the 23rd of October 2024. This session is a short version of a longer session, and I had made also other 4 sessions that I had submitted to be able to present potentially at JFall 2024 this year. Unfortunately, none of them made it to the conference, but I did get to present this short version on the second class of the Master Speaker Academy sessions. So this session is about CRaC in Spring, which means Coordinated Restore at Checkpoint. For those of you who don't know, the Master Speaker Academy classes is something that the Dutch Java user group organizes, I think, every year. And I don't know how many sessions they have every year. This year there were 2. And the idea is to train people to present at conferences. The idea is to give them a space to ask questions and to check out the points that they may have that need improvement, and to learn more about how to present and how to deliver on stage. We also go around things that should and should not be said on stage, and there's a whole range of topics that are discussed surrounding that matter. These sessions are not so much focused on the content of the presentation, but much more on how we deliver that content, and also about how do we write a good abstract to convince an organization that our presentation is good to present at their conference. And that is in a nutshell what the Master Speaker Academy is all about. And I can say from my experience that it was good to present there, and it was good to have gotten the feedback. But more on that at the end of the presentation. Right now, I'll just give the same presentation in this video so that we'll learn a bit more about what CRaC is and what it works. So this is my presentation. CRaC in Spring, I just froze my service. So what is, in a nutshell, Project CRaC? What does it allow us to do? One important thing is that, and probably the most generic one, is to keep the state. When we start Spring, it does a lot of things, and I will explain in a minute what those things are. But what CRaC addresses is the possibility to save those states and to be able to start Spring at a checkpoint after that, so that we don't have to redo all of those things. But more on that later. Let's go to the next slide. So first, who am I very quickly? My name is João Esperancinha. I come from Portugal, and I studied at the Instituto Superior de Engenharia de Lisboa. That's of course in Lisbon. And I studied telecommunications and computers engineering. I am an OCP 11. I am a VMware Spring Professional 2021, and I also am a Kong champion. I love plants. I like to make furniture now and then with all parts of other different furniture, and I also love nature and to walk in a park. And this is actually a picture of me at the top of a castle that exists in a place called Manderscheid in the Eifel in Germany. And I'm the owner of the Just Protect channel on YouTube, the channel that you are now watching. So what is Coordinated Restore at Checkpoint? So I've just given a hint of what it actually is, but the idea is that we are able to mark our service while it's running with a checkpoint, which is where we'll always go back to if we want to start the service again. And we will see the benefits and perhaps the caveats of it. So what do we need to solve here? We need to solve startup times. This is in a nutshell what it is. We can get very irritated, as this cat over here, and because it's not just about the startup times, it's everything that gets caused after we have a slow starting server. One of the things that is important to worry about when our start times are very slow isn't so much about how long the service starts, because nowadays a service doesn't take really that long to start, depending on what we are doing. And perhaps if it's taking too long to start, maybe we are initializing too many things and maybe that service needs to be broken down. But if we think about how many times do we need to restart a service because of updates or because of different kind of other infra operations that we need to do, that startup time summed together may cost a reasonable amount of money, if not a significant amount of money, because it is the startup time of the service at the time that that service is down. But the story of Project CRaC begins years and years ago. Back in the 2010s, there was an application called CRU, which is still used today. This is a command line application that is used in Linux systems to pause applications and restart them later. It's called CRU, and CRU means checkpoint restore in user space. The idea was to mitigate fault tolerance and to manage processes. And this idea remained there up until 2021, where CRaC started being developed. And it started being developed with the idea of coordinated checkpoint and restore operations. The idea was we would prepare a checkpoint, save the state of a service or a JVM application, and then restore that later. And it began to be defined what a checkpoint should look like and what a checkpoint actually is. Between 2022 and 2023, lots of experimentation started being done in frameworks like Spring and Quarkus, up until 2023, where Azul releases the first JDK based in this case on JDK 17 with full support for Project CRaC, a version that is a long-term support version, an LTS, that is only available in Azul, not yet in the OpenJDK versions. So if we want to use Project CRaC, we need to have a JDK that supports it. And supporting it means that it has the command line CRU incorporated in the JDK. And it's literally a physical location inside the JDK folder structure. But we will see that later. So what is a coordinated restore at checkpoint? What does it mean and what can it do for us? A checkpoint is where we freeze the service. So literally where we can say, I froze my service. Remember the picture at the beginning of this presentation? In the opening on the right, we had this photo over here. This is the photo op that I did on a server photo and just added some snow to it, just to say it's frozen and we are going to start it later from that point. It's kind of what it means, a checkpoint. But a checkpoint means a lot more in this case. It means that the application resources are kept and that there is a coordination between the JDK and the state of the JVM at that point. A checkpoint will close files. When we create it, we close files. Connections, we dump the cache before the checkpoint. When the checkpoint is created, we can keep that state somewhere, for example, in our physical medium, our hard drive in a folder, and we can restore that service later. And when I mean service, I don't necessarily mean Spring, I just mean any JVM application. The restore doesn't start the runtime from the checkpoint. This is an interesting thing to mention because we may get the idea that when we restart at a certain checkpoint. The thing is, we will see that a checkpoint can be created programmatically, or we can create a checkpoint by calling a certain command that will stop our service and will create that checkpoint for us at that specific point in the runtime of our application. But it can also be done programmatically. But in either way, there is a process that always starts, and that is the initialization. So that means if we have a auto-executable application, for example, the Spring Boot application, the main gets always called. It's just that the state of the application remains there. So what do we need to get Project CRaC to run or to enable it in our running application? We need the CRaC library. The CRaC library needs to be installed regardless of what framework we are using. It's just something that we need to be able to create the checkpoints and to be able to allow our application to receive requests to also create those checkpoints via the command line. As I mentioned before, we can create it via the code programmatically, but we can also do that with calls from the command line. We also need, if we are using the Spring framework, we need the Spring modules that allow our application to run as a service. And those are many times just the Spring Boot Starter Web and the Spring Boot Maven plugin. And we also need a CRaC compatible JDK version. And Azul provides us already with a JDK 21 based version that is also compatible with CRaC. So we only need to find a version with these combination of names. Zulu for Azul, CRaC for Project CRaC and 21 for the version that we are testing in this example. So how can we create a checkpoint? The first thing we need to know is that the only possibility to create a checkpoint, even though we have compiled our code with a JDK, and even though we are running it with a runtime environment that can support Project CRaC, we cannot do anything unless we start our application this way, because if we run our application with CRaC, it needs to know where it is going to dump the state of the application when we make a call to create the checkpoint. We also need another thing, and this is for optimization purposes. It's not a must, but is a must if we want to make a case to use Project CRaC. We need to make sure that our application gets enough requests so that we are sure that the application is busy enough so that we trigger it to perform all the runtime optimizations that it needs to do, namely the just-in-time compiler optimizations. Because when we start the application is made so to start as fast as possible, but the code is not yet fully compiled. There is always compilations that need to be done during runtime, and those things can impact the startup of the application, and because of optimization reasons, they are done during the runtime of the application. But what we want in our checkpoint is that we can trigger all possible optimizations so that when we create the checkpoint, all of those are already done, so that we can start the service again as quickly as possible without the need to perform those optimizations. And the other thing that we need to do is, and this is the point where we create our checkpoint, is either we create the checkpoint programmatically using this instruction over here. This comes from the C.R.a.C library, and this is just a call to checkpoint restore. There are many other options in the CRaC library, but this is the typical one that we use to create a checkpoint. Or we can also create the checkpoint via the command line, and that is generating that folder that we've seen before. And this is by the use of the Java command. And then we can use this J command target CRaC service Java jar with JDK checkpoint to create that checkpoint for us. Essentially, this is just a Java command using this target CRaC service java.jar to find the process ID of the running application, and it will then apply one command from a set of commands from the Java development kit, in this case the checkpoint, which will then create the checkpoint for us. And now that we know all of that, at least we have memorized something of what we need to do. And now that we know how to compile our application, run it, start it, and we also know how to stimulate our application to perform all optimizations, and we know how to create a checkpoint, let's now make a demo and see how these things work in real time. So this is our project, and this project is located on GitHub. I will tell in the slides where to find it, but that will be later on. For now, let's have a look at the two different modules that are necessary for this demo. One is the CRaC Runner Java, and the other one is the CRaC Service Java. CRaC Runner Java is a simple Java application that has been made runnable, and the other one is a CRaC Service Java, which is the Spring Boot application example that I will show later on. The CRaC Runner Java application has been implemented with a Java code, and it is using Maven to be built. The Maven file, the POM file here, is configured in the following way. We are using as a dependency the CRaC dependency, and here we are using the Maven Shade plugin. This is to make our application runnable. For those who know the Shade plugin, we define the main class over here, and we also need this transformer to make the manifest for us so that our jar becomes runnable. In any case, this will make sure that we get a jar in the end, but the code is essential for our understanding of how CRaC works. In this case, we are creating a CRaC runner, and this CRaC runner is implementing a resource in an auto-closable interface sys. The auto-closable interface is just a handy interface for the code. It isn't absolutely necessary for the CRaC implementation. The resource is, and the resource is an interface that has two abstractions. One is a before checkpoint, and the other one is an after restore. The before checkpoint is an implementation that we need to provide so that we can get this called just before the checkpoint. And before the checkpoint means that we send a command to our service via code programmatically or via the command line. And that means that at that point, this gets called, and then in this specific example, we are calling before checkpoint, this printout, and then we are adding one to this count over here. This count over here is an atomic integer that will register just an integer value that represents a state, because it's part of our example to show how CRaC keeps states inside a dump file or files in a folder. And then we also need to provide the implementation for the after restore. And the after restore can be a bit nuanced, and so it's important that we zoom in and see how this works theoretically, and then we will see in practice how this actually works. The after restore gets called right after the application is restored. This seems very logic, but we can have two different interpretations here. One interpretation, we could think that it starts after the application starts. As we've said before, the main method is always called, so we could think that this gets called only after the main method gets called, but it's not that. After restore starts just before the main gets called. So just before the application starts, the application is restored, and that time in between, that is when the after restore gets called. But this doesn't explain yet how does this CRaC runner will run for us, because we know if we create objects in Java, they don't do anything if they are not inside some kind of context, inside some kind of framework. But that is what happens in a constructor with CRaC runner. Right over here, we are calling the global context of the CRaC environment, and we are registering the CRaC runner, like this over here, as something like the beans work in Spring. If you remember, in old versions of Spring, we would create beans and we would inject those beans in the Spring context. That is not necessary anymore, thanks to annotations and that kind of thing. But here we are registering the CRaC runner manually in the global context. And that means that it gets activated. But where do we call this, and where do we call the constructor, and where does the CRaC runner gets built? Well, that is right over here. If we follow the way the main works, we will see that it's printing out the runtime version. This is the Java version. It will print out to the console, and then it will add a 1 to the counter. If the counter is 1, which will be on the first run of the application, it will then do a try catch, a try with resources. That is why we have the auto-closable interface. And then we do another try inside of it to see if we can call these two lines of code correctly. It will first call a print line that will print out process will shut down with process ID into the console, and it will print out the process ID number, and then it will call checkpoint restore. And if you remember from the slides, this is where we say to our application programmatically that it needs to shut down and save the state on that folder that we specify at the beginning of the start of the application. At this point, the application has stopped, and if we do a second run, what will happen is that the code will start running here, but in this case, it will not have a count of 1. 1 has already been added, and after the restore, another 1 has been added. But before we stopped the service, we also added a 1, so that's already 3. And so here, the count is set to 3. But we are adding 1 again when we start the application. So now that's 4. So that means that it is 4, so it's not 1. So it will go into here, where we will print out the process ID of the running application again, and the counter, which should now say 4. So let's run this application. And for that, and for all the operations that we are running in the command line, I have created a makefile that has all our commands nice and neat set into this file, so that we can go through them easily and better understand how this works. So the first command that we need to run is, of course, the maven clean install, And before we run it, it is always a good idea to check if the version is the correct version. And as we can see, I have the correct version. This is the CRaC version of the JDK 21, and it comes from Zulu, which means the Azul systems. So let's now just build our application with build Maven. In this case, it's just your typical Maven clean install. So this created our jar file, and we can check it right over here in the target folder. We see that we have the original one, which is not a runnable file, and this one is. So now we've got our jar that has been compiled with a CRaC enabled JDK, and now all there is to do is just to start our application. And so if we do a make start CRaC classes, we should expect what? That the application stays running? The application will stop immediately. As we have seen before in the code, it will call immediately the checkpoint. So that is this method right over here, the checkpoint restore, and therefore it will stop immediately, but it will create the temporary folder with all of these files that are the states of our service, or in this case, our application. So if we look at the printouts to the console, we see right over here the runtime version, and then we see here the process ID where it has shut down, and then finally we see all of these logs that are just related to the CRaC library. Now we have a checkpoint, so we can now start our application from that checkpoint. Then we can do a make restore CRaC classes. We have restored our application and it has stopped immediately, but not for the same reasons. Now the application has ran successfully, and we can see that the counter is set to 4, and we can also see that it has printed out the release version. It has printed out the after restore, as we expect from our restore method implementation, which means that we've got over here the system out print line after restore, and it has added 1 to that counter. And as expected, we get the release, and then finally we get that the counter is 4, and we also say that the process will continue with the process ID of this new application. So this is the restore, and if we do it again, if we call the restore again, it will restart always from the same state. So no matter what we do, the counter is still 4, it will still do the after restore logout, it will still print out the runtime, and it will still do the printout of the process ID and the counter. So with this, we have created a checkpoint for our simple Java application. But this can be a lot easier with a Spring Boot application, and that's what we have right over here in the CRaC service Java example. So let's go right over there, and here I just want to show first how the Spring application is configured with the Maven file, and here we are simply just giving it a simple Spring Boot starter web package, then the CRaC library, and then for testing the Spring Boot starter test, which let me just correct that because the scope here has to be test. And then we've got over here the plugin with a Maven plugin for Spring Boot, and where we specify also the entry point for our main application, and here just a simple goal of repackage just to make sure that we always get a jar with Maven clean install. We can now have a look at the source, how it looks like. It's just basically a simple REST service with all of these endpoints. It has a scheduler here, and it also has the scheduling enabled, and it's just a simple start of a Spring Boot application. This is the traditional way of starting a Spring Boot application. It is also Spring MVC, so it is super traditional, and it is the most common form of Spring applications that we can find. So let's now try and do this for a Spring application. And of course, for that, I also have a make file. And if we look at the make file, it has all of these different scripts. One part of the scripts that you probably have seen as well there before in our Spring, you probably have seen there as well before in our Java application. We are giving the permissions to Creo to be able to run, but this is something that you only have to run once in your machine. And then we've got the start service CRaC, we've got the start siege, and we've got the create checkpoint, which is basically when we stop the application, and then we've got start checkpoint, which is starting from that checkpoint, our Spring service application. So let's first build it, and for that I need to go to that folder C.R.a.C service Java. Let me just commit this. This is a Maven scope correction. Okay. All right. So now we are inside the folder of the service. We can just simply make. We can just simply make build Maven over here, just in the same way as we did before. Build Maven is again a simple Maven clean install. And now we can just start our application. Start service C.R.a.C. Right, it has taken a while, 1.4 seconds, and now the application is running. In another tab, let's now go inside the folder of our running application, and now let's just create our checkpoint. And for that, let's have a look at it again. We are now using the J command, so the Java command, to get the process ID of our application, and then we will apply the checkpoint command to it that comes with our JDK. So if we do make create checkpoint, it seems to have ran okay, and we see the same message here. If you notice, we also got this checkpoint ... in the simple Java application, and in this case, if we now go back to our folder, we should see a temporary checkpoint. And here, this is where all the dump of the states of our application resides. But I forgot to do something. I forgot to charge the application with a lot of requests. So let me just stop the application right over here, and let me just remove the temporary checkpoint folder. And this requires this. Okay, so we've got rid of the temporary checkpoint folder, and now let's just start the application again. Make start service C.R.a.C. Okay, so the service has now started in 1.3 seconds, and right now we are ready to charge our service with different requests with command siege. And for that, we can go over here to this outer tab, and here we can do a make start siege, which is this command right over here. And what this command does is it creates one single client which will start sending requests up to 100,000 requests to localhost. Let's see what happens if I start siege and run the command. So now it's just sending all of these requests, and it will send these requests on the basis of request response. And so I already noticed that the machine is doing a lot of stuff, and it has already completed. And that means that all of these requests were sent without any delay between them, and that is what this switch means, the -B. So 100,000 requests, only one client, and we can see that it has performed 100,000 transactions very quickly, and the elapsed time was about 12 seconds. All right, so now we have sent the request, so that means that our service is now ready to receive a request to create a checkpoint. So we can now go here to the command line, and we can run make create checkpoint. And the create checkpoint, let's have a look at it, what it does. It is a Java command that is being sent, getting the process ID of the C.R.a.C service java.jar, and then performing the command checkpoint from the JDK. this command should trigger the creation of a checkpoint. Let's see if that's what it does. And if you've noticed this setup, it's only because that I want to have the right JDK installed every time I run a shell. So this will run a new shell every time we start one of these commands. And this setup, that is exactly what it does. If we have a quick look here, it just installs the necessary environment variables for SDKman, and then it installs the right version, which is in this case, for this particular version, the JDK 21 CRaC Zulu. So, but here we are going to create now the checkpoint. So let's do that. We have created a checkpoint, and as we can see in the command line output, we can see checkpoint ... in a similar way that we have seen in our JVM application. So it works almost in the same way, except that in this point we are creating the checkpoint from the command line and not from the code. If we go now to our other tab where the service was running, we see that the service has stopped right over here. Okay, so now the service has stopped. We've got a temporary checkpoint folder created. And now I didn't forget to run siege. We know that the service took, in the first instance, 1.3 seconds, and the first instance, the very first, when I forgot to run siege, it took 1.5 seconds. How long would it take now if we restore it? So restore is the command that we can run over here. So now we can start our application from our checkpoint, and we can do that calling this command. This command first starts what I've mentioned before, the setup of our JDK, and then it will restore from this checkpoint, which is this folder that we have created in our project right over here in this one, this folder over here, and then we establish the class path to be this one over here. By doing that, we are enabling our application to be able to start from that checkpoint onwards. We now know that the just-in-time compiler has run, that the application is probably as stable as it can get, and it is as optimized as it can get. So all of that stuff is out of the way. So now when we start the application, we expect it to start really quickly. So let's see if that is what happens. By starting the application with this command, the C.R.A.C restore from, which is enabled with the switch. So let's call it. Let's call make start checkpoint. And the application has started very quickly for 30 milliseconds. Now you probably have noticed that there are these logs coming in. This is not part of the CRaC framework. This is something that I have created and that I've briefly mentioned in our code right over here in the controller. I have set here a scheduled, and this is to show a phenomenon that is probably still happening with this latest version of CRaC. And what it is that this schedule seems to keep on going even when we stop the application. But I explained all about that in a video that I have created before. You probably see that video somewhere now in the screen. I will put the link in the description for it so that you can see that investigation that I did on Project CRaC. But coming back to our application right now, let me just stop this. So we have now seen two different ways to create a checkpoint. So we have seen now how to start applications with CRaC enabled capabilities. We have seen how to create a checkpoint. We have also seen how to monitor those checkpoints with the resource interface and implement those abstractions to see what happens when we are restoring our application or we are creating the checkpoint. And we have also seen how to start our application from that checkpoint in a simple Java application and in a Spring Boot application. These are the basics of Project CRaC. And of course, there are lots of different options in the C.R.a.C library. So now let's go back to the slides and continue the presentation. So if we go back to our slides, we were right over here. And here we are asking, how can we monitor the start and restore? So as we have seen now in the demo, we now know how to do that. And that is basically with resource. If we implement resource, we can monitor exactly what happens before the checkpoint and just after restore. And as a recap, we already know what this restore means, right? We know that the restore occurs just before the application starts in the main function. How can we restore a checkpoint? We also have seen this. We can restore it from a folder that we hand in with this command -xx:\crack restore from. And for more complicated applications, we need to probably give in our jar and the entry point of the application, in this case C.R.a.C runner. But there are different options for this, the ones that we have seen in our make files. But why would we need this anyways? What does C.R.a.C solves in terms of the problem that we have seen before? Now, we have reduced the startup time from 1.5 seconds to about 20 milliseconds. That can be a lot, especially if we are working with things that need to restart a lot. But it depends on your project. Sometimes you don't need this, but sometimes it can be useful to think about that because of costs. But bear in mind that using Project C.R.a.C for these things, although it is very useful to save on startup times, it will compensate that by needing to use more space in your disk to be able to store all of the states that the service needs to store. And some initializations will still need to occur in spite of saving the states. So of course we need this for faster startup times. We have seen it before, we have talked about it. We need it also for reduced warm-up time for the JVM. Warm-up time is just another way of mentioning what jitter does. So the just-in-time compiler, this thing that we use when we start up our application, we use it implicitly, and it basically optimizes our application to run more efficiently and smoothly. And the reason why it is there under several others is mainly because we want to start our application as fast as possible. It does present cost savings in some situations for cloud environments, or maybe for a lot of situations. It really does depend on the use case and if you really want to use this in your cloud environment. But one thing it does for sure is saving startup times in terms of space and time. It is something that for your project you need to think about what are the effects and maybe do some benchmarking tests and maybe do some integration tests and try to find out if this is a good solution for you. It improves the elasticity for microservices. So you can imagine that if we are talking about auto-scaling, we are also talking about restarting services. And one of the things that triggers a better auto-scaling and more efficiently is a fast restart of services. So Project C.R.a.C can really be important in these kind of situations. And it enables stateful workloads. So this means that if we need to work with a stateful machine, which is not advised, but if we want to use some kind of state in a service, we can always restore to a checkpoint of interest where we want to restart our application from. Now, there were questions presented when I gave this presentation at the Open Value headquarters for the Dutch Java user group. There was one question about logs that I still need to investigate further. It won't be present in this presentation because I consider it to be a more advanced question that would probably require a much longer presentation, which I will do about Project C.R.a.C. But this video is about that presentation that I gave there. And there were other questions surrounding how exactly this works and why didn't I give a demo, and important questions about the presentation. But one reason why the demo didn't occur was because the idea of giving the presentation for the master speaker sessions was to train presenting, and we were only given 15 minutes slots. I think there were probably more than 15 minutes in other presentations, but I wanted to respect that requirement of the 15 minutes. And so when I did the training to do my best to give this presentation in 15 minutes, I wasn't able at all to save some space and time to make a demo. And as you have seen, we are already really gone above those 15 minutes for this video alone by including that demo in this video. Another thing that it was told was something about the order in which the slides were presented. So these slides are actually not the original. They have been improved in terms of presentation, but in terms of the order of the slides, the idea was what I just mentioned about the use cases for Project CRaC is a short description of where it can be used. There are probably much more use cases that I still don't know about Project CRaC that would probably be very useful to bear in mind. But the idea starts always from one single point, that we just want our services to start faster. And that I did present it in this slide over here with this little angry kitten waiting for things to run. And so the idea is to solve this problem and to make this kitten happy. As far as I can remember, these were the most important questions that were asked to me during this presentation. There was a question about safety. Apparently there are some aspects of CRaC that still need to be refined, where potentially there could be safety risks around there. So make your due diligences and make sure that you know which aspects of this framework are you using and which of these aspects can potentially bring a security risk. So I'm saying this presentation helps you maybe get a first step into the world of Project CRaC and Project CRaC if you are not used to working with Linux. But it is not a place where you can just stop learning about Project CRaC because you know now a lot about it. Now, if you are thinking about using Project CRaC, make sure that you make your investigation first. In the slides, I present the resources that I've used. One thing I have to say about this presentation, Project CRaC has been presented by other people in many different ways. And this presentation per se is not really an original presentation. My interest in Project CRaC started when I first saw one episode of a podcast, which is a podcast about Spring done by Dan Vega and Deshaun Carter, I think. And in one of those presentations, they talked a lot about Project CRaC, and I was immediately fascinated by it, and I did a video about it because when I found out there was something strange going on with the schedulers, I wanted to make a video about it, and that's what I did before. But yeah, the resources are here. I've learned a lot from them, and this presentation is a bit of a short summary of what I've learned in these resources. So please have a look at them. They are all very interesting, and there are also videos there about it. This is the source code about what I just did. So the JE.org Spring Master Task Drives is where you can find the Java examples. If you are interested in the Kotlin version of this, you can find it as well in another repository that I have. This is another project called Asensai the Right WAF. This project is a compilation of very varied projects and modules for different videos that I create on my YouTube channels, this channel. And at the last point, I've got the one crack for Spring Unexpected Behavior. And this is the video that I created before about the schedulers. Now, important to mention are the lost presentations for JFall. So this year I put a ton of efforts to try and get through to JFall, and just for you to get an idea, if you are trying to do presentations for the first time in conferences, let me tell you, it is massively frustrating. It is so frustrating that sometimes you just want to quit and not do it, because you are likely going to put an extreme amount of effort to make a very nice draft, to make a very nice text to apply to do a presentation in a conference. You may as well make videos about it. You may as well do a ton of work, contribute to open source projects, and you may still get rejected a lot of the time. And JFall is no exception. JFall is a conference that is growing every year and getting bigger every year. So it is a highly prestigious conference. So that means that a lot of people are trying to sign up to present at JFall. And of course, odds are that it's not going to happen. But I will try again next year. But let me just go shortly over the different presentations that I have sent. Those were 5 of them. One of them was called "Could Virtual Threads Cast Away the Usage of Kotlin Coroutines? What Experience Can Tell Us?" I actually ended up, just by pure coincidence, making a presentation about this at the London Java Community Group in London, which I went there specifically for. And that was a great experience there. And this presentation was more about, now that we can use Java Virtual Threads, what does that mean to the usage of Kotlin Coroutines, and how does that changes the landscape, if it changes the landscape at all. The other presentation was integrating arrow optics in a real-life scenario, my personal life experience in a parallel world. So at this moment, I'm also using optics, and I'm also using Java Virtual Threads for work and for as a hobby. And I had created a scenario with spaceships to show how to use arrow optics. I found it very interesting. I had everything prepared and ready to go, but it didn't went along. I'm still using this presentation to apply for meetups and also for conferences, but still no answer back. I probably will improve that presentation and try and get it to go through. The other one was Kotlin Mysteries found from years working with Kotlin. Now, this presentation is also another one that I did, also out of pure coincidence, which was a conversation that I was having in my in a social media account. This was for now called X, which I don't have an account anymore because I deactivated it for, I think, for obvious reasons in current times. But during that time, which was around April this year, I had a very active discussion about Kotlin with different people from Germany, from the Netherlands, from other countries. And it was an amazing discussion that led to me being invited spontaneously to do a presentation at JetBrains in Amsterdam. And there I talked about things in Kotlin that may not be obvious to your everyday programmer, but especially for people that come from a Java background. So that was an interesting session. I've got a lot of compliments for it. I love doing it. It was my first presentation in years, and now I think I have about 4 presentations done in meetups. But this was my first one this year. For JFall specifically, I had to change the first presentation to "Finally, we can simplify our code with Java Virtual Threads and do away with Kotlin Coroutines." This was a presentation more strictly made so that it would fit into the standards and requirements to present at JFall. So this presentation wasn't one that I did spontaneously. This was done together with the team that runs the master speaker sessions. And another one that was also made possible and improved by the master speaker sessions was the improved startup times with Spring CRaC by freezing your Spring service. So this one was a presentation that I also improved a lot with the help of the Dutch Java group, and it was also one that I've sent to apply to present at JFall. But unfortunately, none of them succeeded. But I will keep on sending these and maybe new presentations to other conferences, and surely JFall next year, and we'll see how it goes. Finally, if you have seen the video up until this point, congratulations and thank you so much for watching it until the end. And make sure to stay tuned to this channel because there are massive changes coming in, especially to the video shorts, given also the new changes in the YouTube algorithm and what has been changed and has been done there. There will be more long form videos coming in, and there are a ton of quizzes in the community tab. If you don't know about this, the community tab has been having a massive follow because of the enjoyment that people are getting from the quizzes that I am making there. I make sure to do at least 10 quizzes a day if I have time for them, but at least that is my goal. It doesn't mean necessarily that I make the 10 quizzes a day, but I try to do that. And yeah, if you enjoyed this video, just make sure to give it a like. It is very important for the channel, and make sure to subscribe. Don't forget to leave a comment in the video. Your comments are great. I've been enjoying a lot the comments that I've been receiving so far, and it makes the channel look great, and it only makes the channel better. One more thing. This is the About Me section of the slides. You can find here that I have a homepage where you can see also some blog posts, which I also do there. I have an account on Threads, which you can follow. I'm more active on Threads and Blue Sky and Mastodon. However, Threads is the best place to reach me. LinkedIn, I'm also there. Then I also have an account on GitHub, of course. This is where you can find those projects. And I have an account on HackerNoon, Dev.to, and on Medium. The articles of Medium, I say this now for the past videos that I've been posting, they are all for free now. They used to be monetized, but I decided that the content should be made free for everyone to read, should they be interested in reading what I have to write. So, having said all of this, thank you very much for watching, and I'll see you in the next video. I just want to throw out a big thank you to the Dutch Java user group for organizing this session that was given completely free and through the hard work of volunteers. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.